quadrilaterals and other polygons. We're going to continue with the geometry section of the math. Okay, copy the title. Most of the time in geometry, in polygons, we just care about quadrilaterals, but we just mention other polygons because sometimes the SAT does get creative with other polygons. Okay, so what is a polygon? So a polygon is just a closed figure with straight sides. Just like a triangle is a closed figure with straight sides that is created by drawing three straight lines, right? So a polygon is just a closed figure with a number, any number of sides, which means a triangle is a polygon. So regular polygons, they're called regular because they have an equal an equal measure of angles and an equal measure of sides. And from here we have the most popular, which are the quadrilateral with 4 sides, the pentagon with 5 sides, and the hexagon with 6 sides. Pause the video, copy these. These are just definitions. We're going to move on. We're going to start seeing quadrilaterals. So what we care about quadrilaterals, we mostly care about rectangles and squares. So a rectangle is just a polygon with 4 right angles, and a square is a rectangle, so it's a quadrilateral with 4 equal sides. Okay, which means a rectangle, okay, is just any figure that has 4 right angles. And the square also has 4 right angles, which means the square is a type of rectangle, but it's a special rectangle that not just has 4 right squares, but also has 4 same angles, 4 equal sides. Now, you could also say that a rectangle is a type of rhombus. It's a rhombus with 4 equal angles, but don't worry about the definition, don't worry about the terms, just worry about what they are. Okay, pause the video, copy this. We are going to move on. Diagonals. So here's what the deal about the diagonals for squares and rectangles. In a square, if you draw the diagonals, first of all, they're going to have the same length. They're going to cross at a 90 degree, and they're going to be separated into equal sides, which means this is going to be equal to this, equal to this, equal to this. When you draw the diagonals in a rectangle, all you do is you draw 2 diagonals that have the same length. They don't necessarily intersect at a 90-degree angle. They can intersect at any number of angles, but they do bisect, which means they do cross. This is equal to this, and this is equal to this. Okay, copy this. We're going to move on. Area of a square, the area of a square is just the side square, but if you want to use the diagonal, it's also half of the diagonal square. You can use both to find the area of a square. If you don't remember one, don't worry, you can just use the other one. Okay, an area of a rectangle is just based on base times height. If you notice, the area of a square is also base times height. It just happens that the base is equal to the height, so it's basically side square. In this case, when you have a parallelogram, you can always just turn your parallelogram into a rectangle, so it's also base times height. If you think about it, it's because if it's a regular parallelogram, then you can, this triangle over here, you can paste it over here, and there you complete your rectangle. Pause the video right here, copy everything. Yes, these are formulas that the SAT will give you, but it's still important that you, again, as I said, at least have it in your mind so you can recognize. A trapezoid. A trapezoid is a quadrilateral that is formed by 2 parallel sides and 2 non-parallel sides. An isosceles trapezoid is determined by a trapezoid that has equal non-parallel sides and equal base angles. When you have this type of figure, you can find the area by adding the base, so the base, all of the length of the base plus the length of the minor base, divide by 2 and multiply times height. Pause the video, copy this. We are going to move on. What is the strategy? Well, the strategy is pretty much the same as in geometry in general, right? We draw the figure, we draw everything, but draw as many lines as we can. But also, when we have complicated figures, what we want to do is we want to divide them into triangles. If you think about it, even when you have a square, right, you can just divide your square into 2 triangles or into 4 triangles, and now you can just practice using, or you can use the formulas and a strategy for triangles. Like, most of these figures can be divided into triangles, so they can be easier to work with. Okay, pause the video, copy this. We are going to move on. I want you to pause the video, solve this question, write down the solution, write down your answer, and we are going to check. So here they say, A frame 1 inch wide is placed around a rectangular picture with dimensions 6 inches by 8 inches. So I have my rectangular picture. So this is 8 times 6, 6 times 8. And around this, I place a frame, right? That is 1 inch wide. And then the question is, what is the area of the frame? I just want the area of the frame. I don't want the area of the rectangle. There are two ways of doing this, okay? I'm going to do it with way 1 and way 2. The first way is actually just finding the area of the frame. So again, so this is going to be 1 inch, right? So from here is 1 inch and 1 inch, which means what I'm going to do is I'm going to separate this into smaller pieces, into smaller areas, and I'm going to find the area of this rectangle, then the area of this rectangle, and then finally I'm going to find the area of these small rectangles, right? So I'm going to get the area of the first rectangle. So this full length is going to be, since 8 plus 1 on the left plus 1 on the right is 10, and is like 1 inch. So the area is 10. So it will be 10 plus the second area plus 10 plus, now I'm going to find the brown area. So this is 6 times 1 is 6. So 6 plus 6. So I have 10 plus 10 plus 6 plus 6. I have 20 plus 12, which is 32, which is the answer. That is one way of doing it. The second way of doing it, if you think about it, what I'm looking for is I'm looking for the exterior area, right? The surrounding area. So what I can do is I can find the area of the whole figure, like the whole rectangle, and then subtract the interior area, because that's the thing I don't want, right? That's the second way in which we're going to do it. So we're going to find the full area, right? Like full area minus the interior. So we have the full area will be 10. So this is 10. And this will be 8 because it's 6 plus 1 up, 1 on the bottom. So we have 80. So the area is 80. And from there, I'm going to subtract the area inside, which is the area I'm going to put in blue, which is 6 times 8, which is 48. So 80 minus 48, which is going to give me the same answer, 32. Either of these ways is a correct way of solving this type of questions. You either find the full minus what you don't want, because basically that's what gets you the selected area, or you just divide your bigger area into smaller pieces and find all the small pieces. Okay, pause the video right now, copy this, and we are going to continue. We are going to do questions from Digital SAT. I want you to pause the video right now, solve this question, write down the answer, and we're going to check. Okay, so they say each side of a square, so we have a square, each side has a length of 45, so have 45, 45, 45, 45. What is the perimeter? Well, the addition of all of them, so 45 plus 45 plus 45 plus 45, which is 180. This is the answer, right? Because the perimeter is just the addition of the sides. Okay, we're going to go to the second question. Pause the video right here. Solve this question, write down the answer, and we're going to check. Okay, so I have a square x. Okay, so I have x square x. Has a side length of 12. So 12, 12, 12, 12. And they tell me square y, we have square y, has a perimeter that is 2 times the perimeter of square x. Okay, so the perimeter of x square x will be 12 times 4, so it's 48. So the perimeter of square y will be twice of that, so it will be 96. And now for us to find the side, all we have to do is divide 96 divided by 4, which gives us 24, which is the answer. Pause the video right now. Copy everything you have to copy. And if you want to practice more, this is the chapter of the Barron's book where you can practice. In this case, there is no chapter of the Panda book, but you can practice using Khan Academy or practice tests.